Hello everyone, I'm Dr. Farhan Saeed, working as Associate Professor in the Department of Polymer and Process Engineering, University of Engineering and Technology, Lahore, Pakistan. Today's my talk is on the role of commercial and economical nanofillers in the plastic compounds for automotive industry. In today's talk, I will discuss about the classification of fillers in local automotive industry, the particle size of fillers and their effect, the presence of the active sites on the surface of the fillers, the effect of the fillers on the mechanical performance of the different automotive parts, and at the end I will conclude my presentation with the ending note. We mainly classify the fillers based on their performance, for example, reinforcing fillers and the non-reinforcing fillers. But in our local Pakistani industry, the fillers, they are classified based on the color. So that's why we can classify the fillers into two different categories. One is the black filler, second one is the non-black filler. In black filler, we mainly use the carbon black as our main filler. There are different grades of carbon black which we can use. In non-black fillers, there are various particulate-like materials, just like calcium carbonate, silica, talc, and precipitated silicates, which we can use. And there are some plate-like materials, just like the kaolin clays, which can be used as the non-black filler in manufacturing of different automotive parts. So the broader classification of filler based on the color doesn't restrict the automotive parts manufacturer on the one category of the filler. They can have the hybrid filler as well. They can use the combination of the black and the non-black filler. Mainly black filler, they are used in those parts where we need the black color. Apart from the black color, we can go for the non-black fillers. And if we use the hybrid fillers or combination of both black and non-black, definitely our compound color would be the black. So in our industry, mainly we classify our fillers based on the colors rather than their performance or their reinforcing mechanism. There are different factors which affect the activity of the fillers, which include the particle size, particle surface area, particle shape, particle surface activity. Although these factors, they are very important in the selection of fillers for different parts, for different applications. The particle size is very important because there are different type of fillers available in our market, which are in the micron sizes or which are in the nano sizes. Just like three main fillers in our industry, the calcium carbonate, carbon black, and silica. Out of these three fillers, the calcium carbonate, that is mainly present in the micron sizes, whereas the silica and carbon black, they can be present in the nano sizes. The particle surface area, that is very important in terms of the reinforcement of the filler. Better the surface area, better would be the reinforcement of the filler with our polymer. The surface area can be enhanced by different methods, by different surface treatment methods, which are available for different kind of the fillers. Then particle shape is also very important criteria because there are different fillers which are present in the particulate-like nature, and there are different fillers which are present in the plate-like nature. Just like calcium carbonate, carbon black, and the silica, they are particulate fillers. Their shape is the spherical, whereas the kaolin clays, they are present in the plate-like structure. And particle surface activity is also very important in the sense because there are different type of the active groups present on the surface of the filler, and those active groups, they they interact with each other, or they interact with the polymer chains. By this interaction, they they create the reinforcement mechanism, or they make the aggregate and agglomerate of the fillers, which are present in different compounds. Then we will first talk about the particle size, which is available. Uh, uh, Particle size of the filler is very important in terms of the selection of the filler for different applications. We have the different classification of the filler, just like the non-reinforcing, semi-reinforcing, and the reinforcing filler. Mostly this classification, they are based on the size of the filler. The fillers which are in the nanometer sizes from 0 to 100 nanometer, they are mainly classified as the reinforcing filler, and silica and the carbon black, they are the two main fillers which are used in the our local automotive industry as the nano-fillers, whereas the uh, uh, precipitated calcium carbonate and the clay, kaolin clays, they are the semi-reinforcing filler which are used in our local automotive part manufacturing industry. There are few fillers which are dry grounded calcium carbonate or the talc. They are having the particle size greater than the few microns, and they are mostly classified as the non-reinforcing filler. If we talk about the nano-fillers, the precipitated silica and the fumed silica, uh, they are the main reinforcing filler in our industry. Carbon black is also widely used, mainly for the black parts. There are different grades of the carbon black, mainly N110, N220, N330. They are the ranges which comes under the reinforcing category, which are in the nanometer sizes. The grades which are having the high structure, they comes under the semi-reinforcing category. After the particle size, the surface area is another criteria which is important for the selection of the filler. Mainly, for reinforcement we need the high surface area, and definitely for high surface area, if we reduce the particle size, we move towards the high surface area. But if we by reducing the particle size we can't get the high surface area, then the surface area of the fillers, it can be enhanced by different surface treatment methods. For example, we can enhance the surface activity of the carbon black by putting them in the furnace or in the oven at the high temperature. So the surface area of the carbon black will increase after some time when we expose them to at the high temperatures. Similarly, the surface area of the silica and the other particles that can be enhanced by different treatment methods. We can also coat different chemicals on the surface of the fillers as well. Then the active sites on the which are present on the surfaces of the different fillers, they are very important due to those active sites. Sometimes different fillers, they can interact with each other to make the aggregate and the agglomerate of the fillers. And when we compound those, we make the compounds using those fillers having the aggregates and agglomerates. It's difficult to disperse those fillers in the plastic and the elastomers. So we need a very high shear to disperse them in the polymers. mainly the presence of the aggregates and the agglomerates, that is due to the presence of the active sites on the surface of the filler particles, just like for carbon black. Or you can see here there are different particles of the carbon black which are linked with each other to make an aggregate, and different aggregates they can link with each other to make the agglomerate. And the interaction of one particle with the other particle, that is due to the presence of different active sites. In carbon black, we can have the hydroxyl group, we can have the carbonyl group, we can have the hydroquinone group, and presence of the different polyaromatic sites on the surface of the carbon, and that is due to the byproducts which are formed during the manufacturing of the carbon black. So if we use these active sites during the compounding of the different polymers, you can see here I take the example of the carbon black, and when carbon black that is mixed with the different polymer chain, and the presence of these functional group or active sites, they interact with the chains of the polymers, and when they interact with the chain of the polymers, it will have the better interaction with the filler and the substrate, or filler and the polymer. So it would give you the better mechanical properties by reinforcement mechanism of filler and the polymer. So the presence of the active sites on the one side, it makes the aggregates and agglomerates of different particles, whereas on the other side, the presence of active site, that is important for the interaction with the polymer chains as well. So if we have better interaction of filler with the polymer chains, mean we have the better reinforcement, and if we have better reinforcement, mean we will have the better mechanical properties of the polymer compounds. So the active sites, they play a major role during the compounding of the filler with the different polymers, because on the other side, one side, we need the high shear for the to disperse the filler in the polymer. On the other side, they would give us the better mechanical performance by reinforcement mechanism. Similarly, in the silica, we also have some active sites which are present on the surface of the silica. We do have some hydroxyl group, presence of the hydroxyl group on the surface of the silica, and we do have some silanol group present on the surface of the silica. And in fact, the presence of the hydroxyl group, that is very tricky in the sense, because hydroxyl group, they can make the hydrogen bonding, they can interact with each other to make the hydrogen bonding, and due to this hydrogen bonding, we do have more interaction of one particle with another particle, and due to that interaction of one particle with another particle, it makes it converts different particles into the aggregates and agglomerates. Just like you can see here, the silica particles, they can convert it into the aggregates and agglomerates, and that is due to the presence of those active sites on the surface of silica. And hydroxyl site, that is more interacting site, because it can provide the hydrogen bonding, and the physical interaction hydrogen bonding is the more active bonding or interacting site, which due to which there would be more formation of the aggregates and agglomerates. If I compare the silica with the carbon black, so I can say there will be more hydroxyl group on the surface of the silica as compared to carbon black. So the tendency of making the aggregates and agglomerates in the silica would be more as compared to the carbon black, because silica is having the more active sites and the more interacting sites as compared to the carbon black. But it doesn't mean that the silica, if it has the aggregates and the agglomerates, it cannot be dispersed. The dispersion can also be enhanced by increasing different dispersing agents, just like we can use the different glycols which help us to disperse the silica and the in the different polymers. But just only dispersion is not the main requirement, because sometime if we disperse the silica in the polymer and we get the better dispersion, still we can't get the better reinforcement, because most of the sites they are filled with the hydroxyl group, and the presence of those hydroxyl group makes the silica inactive. So silica would not give you the better reinforcing property, and that is the main factor, because due to which silica could not be used for the as reinforcement for a longer period of time. But nowadays we do have the some treatment mechanism available. We have the different type of the silanes present, which can interact with the hydroxyl group and which can make it non-polar, or which can make it more interacting with the polymer chain. So when we talk about the presence of the active sites, so in silica the active sites that is more detrimental as compared to the carbon black, and presence of the active sites of just like the silanol or the hydroxyl group on the surface of silica would actually restrict the silica from the reinforcement mechanism. So unless we remove these active sites, or we overcome these active sites, we can't get the better reinforcement in the silica. So to have the better interaction in the silica compounds, what we have to do, we have to treat the surface of the silica with the different treat the surface of silica with the different chemicals. Mainly they are different types of the silanes. They are available. And those chemicals, they are known as the coupling agent, or the bridging agent, or the reinforcing agent. So what we do, we take those chemicals, so we take the silanes, we treat the silanes with the silica, and those silanes, they actually react with the hydroxyl or silanol group, and when they react with the hydroxyl or silanol group, they make the chemical bonding with the silica, and now the active site would be that silane, rather than the presence of the simple hydroxyl or silanol group on the surface. So if we treat it, then after treatment, this silica would be the better filler as compared to carbon black for the reinforcement of the rubbers, and reinforcement of the polymers. And the activated silica, or the salinized treated silica, would give us the better mechanical performance, would give us the better dispersing properties as compared to the normal non-treated silica. And in fact, the carbon black do have some active sites, and those active sites, they are actually the polyaromatic hydrocarbons which are present on the surface of the carbon black. And due to presence of this polyaromatic hydrocarbons on the surface of the silica, surface of the carbon black, it slightly becomes carcinogenic in nature, because the polyaromatic hydrocarbons, they provide or they are the potential carcinogens. So that's why the use of the carbon black should be a bit restricted, and the manufacturing bit should be a bit more controlled, so that we don't have the polyaromatic hydrocarbons as the active sites on the surface, because they are they are not good for the health of the human beings. They are carcinogenic. So we do have a potential carcinogenic or effect from the carbon black. That's why mostly people, they are now moving from the carbon black to the silica, due to the number one is carcinogenic effect. Number two, the performance which we can get from the silica after treatment, that would be much more as compared to the performance that we get from the carbon black. And also nowadays, the oil prices, they are hiking, and the increase in the oil price, carbon black is also becoming a bit more expensive. So silica would be the better option as compared to the carbon black. We did use the different fillers in our. We check the effect of the different fillers on the compound of the different polymers and the elastomers. You can see on your screen there is a graph which is showing the effect of the tear strength with the loading of the silica. As we increase the silica loading from 0 to 6 PHR, you can see there is an increase in the tear strength. So that up to the 5 PHR loading, and afterwards there is a bit decline in the tear strength. So we can see that in the acrylonitrile butadiene rubber, where we have added the chitosan as our biofiller. If we add the silica, we can get the better properties as compared to only the chitosan, which is present at the loading of the 30 PHR. So similarly, the other properties, just like the tensile strength and the elongation at break, that also increases with the increase in the loading of the silica. As we increase the silica loading from the up to 10 PHR, you can see there is an increase in the tensile strength, also in the elongation at break, and that increase shows that the silica can be used with the different other biofillers, just like the chitosan, and it would help us providing the better mechanical performance as compared to the chitosan. Similarly, the effect of the silica can also be seen on the abrasion index. With the increase in loading of the silica, abrasion index of the rubber increases. Here in this case, up to 1 PHR, we get the increase in the loading of the increase in the abrasion resistance of the chitosan filled NBR. But if we further increases the loading of the silica, there is not sufficient change in the abrasion index, and it makes a plateau. So up to 1 PHR, we can say there is a maximum increase in the abrasion index, and onward there is an increase, but that increase is a bit not as much as compared to the up to 1 PHR. So when if we take the example of the different other compounds, just like the PPRC, EPDM blends, and if we look at the properties, the compounds which are having the fillers, silica, and silica as a filler, that shows you the better modulized. Just like you can see here, the compound having the 10 PHR of the rubber content in the PPRC, which and silica up to 5% loading. So it gives us the better performance as compared to the non-reinforced compound having no loading of the silica. Similarly, with the increase in the rubber content, similar trend we get the modularized increases as we incorporate the silica as the nano-filler in our compound. The impact strength also increases in the similar kind of the blends with the incorporation of the silica as a nano-filler. So there will be the effect of the elastomer as well, because we are adding the EPDM in the PPRC. So with the increase in the EPDM content, there would be uh, increase in the impact strength. But as if we compare these with the other compound which are also having the similar kind of the EPDM loading, so when we add the silica, the impact strength of our compound that also increases, and which shows that the silica can also help us in getting the better impact strength in the different plastic parts, which can be potentially used for different application for the automotives. Similarly, we also check the effect of the different hybrid loading of the filler. We had that different, we had the carbon black, we had the silica, and we have the calcium carbonate. Carbon black and the silica both are the nanofillers. Calcium carbonate, that's not the nanofiller, but it's in the micron side. But mainly to make the compound cost effective, we have to add the calcium carbonate as well. In this, you can see the effect on the modulized as we increase the loading of the filler, the modulized of the compound they increases. There's a lesser change in the moduli as we add the carbon black, and there's a more change in the moduli as we incorporate the calcium carbonate. But the maximum change in the moduli will be get when we incorporate the silica as the nanofiller. So out of all these three filler, if we compare, that silica would give us the better increase in the moduli as compared to the carbon black and the silica and the calcium carbonate. If we compare these three fillers in the automotive application, the silica would be the better option as compared to the carbon black and the calcium carbonate. But still, carbon black and the calcium carbonate, due to this cost effective nature, they are more in use in the Pakistani local automotive manufacturing parts manufacturing industry, because at the moment the surface treated silica that's more expensive as compared to the carbon black and the calcium carbonate, but I think in near future it will be the in the same cost range as the carbon black, so industry would move towards the silica as well. So, and also silica gives us the better mechanical performance as compared to the carbon black. So I'm of the view that in our industry, if we move from carbon black to silica, we can get the better results. But at the same time, carbon black is the still good option due to its cost-effective nature, and calcium carbonate is the very cheap, and it is mainly a cheapener in our compound. So we don't look at the properties when we use the calcium carbonate, but we only look at the price effect which we get by use of the calcium carbonate in our compound. So overall, to conclude all these things, we can say that different fillers which we can use, the calcium carbonate, silica, and the carbon black. The silica and carbon black, they are more better option for the reinforcement, and the calcium carbonate, it is the only cheapener in our industry. We don't have the other options which are just like the CNTs which are available as a nanofiller, but in our industry we are not using those kind of the fillers because they are mostly used in the concept vehicles which are having the different parts loaded with the CNTs and the different other things. So in our industry, I think at the moment silica would give us the better mechanical performance, and definitely the industry has to look at the other options of the cheaper fillers which are available locally, just like talc is also available in Pakistan, kaolin is available in Pakistan, but we need to look at the different surface treatment mechanism which are which can be used with the talc and the kaolin to make them more better performing as compared to the carbon black and the silica. That's all for my side. If you have any question, that we can have the question at the end of the session. Thank you very much. Bye.